Hello everyone. This lesson will learn the programming language of PLC. Mainly explain and analyze from three aspects: the introduction of PLC bit logic instructions, the specific application of bit logic instructions, and the logical relationship of contacts. In Siemens PLC, bit logic instructions are the most basic instructions and serve as the application foundation for other instructions. The bit logic instruction clarifies the simple connection relationship of input contacts and the output to the coil in the ladder diagram. Let's learn about the functions of bit logic instructions today. Bitwise logic instructions are instructions specifically designed to handle one bit of binary data, which consists of two digits 1 and 0. For contact commands such as normally open and normally closed contacts, 1 represents action and 0 represents no action. For coil commands, 1 indicates that the signal has reached the coil, and 0 indicates that the signal has not reached the coil. Bit logic instructions are the most basic and frequently used instructions in PLC programming and have different forms according to different functions and purposes. Let's first take a look at the input contact command. Let's observe the first normally open contact in the figure. The contact input command forms are normally open contact and normally closed contact as shown in the figure. When the normally open contact runs in the program and the variable is 1, the state of this contact is conduction, which means there is a signal output. When the variable is 0, the state of this contact is open, which means there is no signal output. The logical state of a normally closed contact is exactly opposite to that of a normally open contact. When running in a program when the variable is 1, the state of this contact is open regardless of whether there is a signal on the left side of this contact. There is always no signal on the right side. When the variable is 0, the state of this contact is conduction. If there is a signal on the left side of this contact, then there is a signal on the right side. If there is no signal on the left side, there is also no signal on the right side. Both normally open and normally closed contacts belong to internal input contacts, and the opening and conduction of these contacts are only related to the bits corresponding to the register and are not related to the normally open and normally closed external input buttons, contactors, and relays. When designing a program, it should be noted that a Boolean quantity should be labeled above the contact as the operand to indicate which variable is the normally open contact. The not negation instruction represents the negation operation of the logical operation result of the contact, which is opposite to normal when there is no signal passing on the left side of the not contact. There is a signal output on the right side of the not contact. On the contrary, if there is a signal passing on the left side of the not contact, there is no signal output on the right side of the not contact. The coil output instruction represents the instruction assigned to the memory which corresponds to coil drive on the ladder diagram. The variable type of the coil output instruction is bool type, and a Boolean operand needs to be labeled above the instruction in the program to indicate which variable to output to. In Siemens S7-1200, coil output commands can be either in series or in parallel and should be placed on the far right side of the ladder diagram when used. If there is a signal on the left side of the coil output command, the coil also has a signal output, that is, the Boolean value is 1. Conversely, if there is no signal on the left side, the coil also has no signal output, that is, the Boolean value is 0. The logical relationship between contacts. The series connection with the logical representation contact, where the contact can be either normally open or normally closed. For example, in the picture below, when a signal passes through I0.1, I0.1 is 1 and I0.2 is also 1. The signal passes through 10.2 and the final signal is transmitted to the output coil Q0.3, where Q0.3 is 1. From this ladder diagram we can see that the logic is represented through a series of contacts on the ladder diagram, and the structure is represented. Each contact must be connected before the signal can finally reach the output coil. 2, or logic, represents the parallel connection of contacts, where the contacts can be either normally open or normally closed. As shown in the figure below, when there is a signal passing through I0.1, that is, when I0.1 is 1, the signal can be transmitted to the output coil Q0.1. Whether there is a signal passing through the other two contacts does not affect the transmission of the output coil signal when I0.1, 10.2, 10. Any signal passing through can reach the output coil. From this ladder diagram we can see that the OR logic is represented by the parallel connection of the contacts on the ladder diagram. All contacts do not need to be connected. The signal can reach the output coil as long as one is connected. 3-circuit block logic. A circuit block refers to a set of contacts connected together in series or parallel by two or more contacts. The NAND logic of a circuit block is represented by treating two parallel contacts as one block in a series structure on a ladder diagram. The OR logic of a circuit block is represented by treating two series connected contacts as a block in a parallel structure on a ladder diagram. Finally, let's take some exercise. That's all, thank you.